Thank you all for coming to this demo. I'm really excited to talk to you today. And my goal is really to analyze COVID vaccine popularity by type in Europe. And I'm going to be doing this using quite a few different technologies. We're not going to go deep into any one specifically, but we're going to use them to solve this problem. And I'm going to give you everything that you need to learn about it in order to follow along. My name is Rabia Imad, and I'm a PM at Microsoft. I work on the Python team. So you can contact me on Twitter or over email if you have any questions or really any feedback regarding this. So with that said, let's go ahead and get started. The learning goals for this session are quite a few. What I want to really teach you is how to transfer data from a file that you might have on your computer to the cloud using Azure Postgres. I want to teach you how you can gather insights to answer interesting questions using Python, because we know that Python is so good at helping us get rapid insights from data. I'm also going to teach you how you can use Fast API to create a backend that will help the world see your insights, both locally and also on the web using Azure Web Apps. I'm also going to teach you how to connect Azure Web Apps and Azure Postgres together so that your web application can talk to your data in the cloud without anything having to be on your computer. And finally, I'm going to help you visualize the data learnings that you have using Jupyter by connecting it to the backend. So ultimately, we're going to have a nice front end that's Jupyter based. You're going to have a backend, and you're going to have some cool insights to share with the world regarding what the world of vaccine type popularity looks like for Europe. So with that said, let's go ahead and get started. Now, there are a few things that I've done for this demo that I'm not going to do in the interest of time. I've installed Python. I've installed Visual Studio Code, which is highly recommended. I have already set up a free Azure account. I've also installed the Azure CLI, which is a command line tool that will help me connect to Azure from my computer. And I also have the relevant code cloned, and the references to the code are all in the slides that were provided to you at the beginning of this talk. So with that, let's go ahead and get started. And we're going to start with understanding data, formulating some interesting questions about this data, and also filtering the parts of the data that we think are going to be relevant to answering those questions. And so what I did was that I ended up going, and that's me there at the bottom left, I ended up going to the ECDC website, which is the European Center of Disease Control, and I downloaded data from it. And it was a big CSV file, and in order to show you what it looks like, I have this table here, and you can see that there's a lot of data here in the columns. You know, you have time, you have doses administered, the number of doses received from the manufacturer, region, population, age, target groups, you know, type of vaccine, so on and so forth. And you can also see that there are a lot of acronyms that are used here, like AT, JANSS, all of those things. And when you look actually at the ECDC website, they actually explain what these mean. And in my code, I've actually illustrated this by having this hash table that maps what these abbreviations mean. So for example, COM is Pfizer, MOD is Moderna, and AT, which is the country listed here, is Austria. So when I looked at, you know, this table, I thought, what are some interesting things that I can answer with this data? And a few questions popped into my mind. One, what is the most popular vaccine for every country? And what is the least popular vaccine for every country? And really, what are the relevant market shares for each vaccine type? And I want to understand, like, is there one group of vaccine that's really dominating the market share right now? Is one really trailing? Is it all evenly distributed? Does it change by country? Does it change by geography? Lots of interesting questions can follow up from this. But once I have this data, I'm going to go ahead and try and find a methodical way of understanding them. But as I've mentioned, when it comes to these three questions, there's only so many columns that are really relevant. And the three that I want to care about are the number of doses received from the manufacturer, which is the first green column, the reporting country and the country that received the doses, which is the second green column, and then finally the type of vaccine, which is the last column. So with those three columns alone, I should be able to answer these questions. So with that said, I'm going to teach you how to set up a database and get the data actually into Azure and have everything ready so that you can connect to it. So I'm going to go ahead into Visual Studio Code. And what I've done over here is that I am going to go into my code repository. You can see that I'm in my EuroPython demo code. And what I'm going to do is I'm going to activate a virtual environment. And what that's really going to do, it's going to help me isolate all of my dependencies so that I have everything installed and ready to go. And the way to activate the virtual environment is simply like this. So once I have it activated, I'm going to install all my requirements file. And in case you're curious to know what was in my requirements file, I'm going to show that to you in just a second. The requirements are actually, it doesn't take very long for them to install, but let's just give it a few more minutes. In the meanwhile, I will actually show you what the requirements looks like. And it's basically just going to install a Python library to connect to the database, that's CyclePG2. It's going to install Fire, UVicorn, Fast API, and easy charts. You actually don't need easy charts. I'm going to go ahead and delete that, but it's in there in the requirements.txt file. So once that is done, I'm actually going to go back to my installation. It's all complete. And now I can go ahead and log into Azure, and I can do that using AZ login. And what it does is it just opens up the browser and asks me to sign in. And as I mentioned, I already have an Azure account, so it's easy for me to log in. However, if this doesn't happen for you, then you probably need to set up a free trial account, and there's a link at the very beginning on how to do that. So once that's done, come back to the terminal, and the output of this is going to be a long JSON type string. And you can, once this is done, it means that you are basically ready to go and use Azure. So I'm going to clear my screen, and the next thing that I'm going to do is turn on something called a parameter persistence. And what this is going to become very clear to you in a short bit. What config param persist does is that oftentimes when we're using the CLI, we use a lot of flags. And so you could end up writing all of these very many flags over and over again, but it can get very tedious. So to save time, you can just do param persist on, and what Azure CLI does is it will remember what the defaults were, and it will make sure to reuse them so that then you don't have to type so much. So once that is done, you are going to want to connect to and actually create an Azure database. And the way to do that is as follows. You can go ahead and write AZ Postgres flexible server, create. Public access all. Now, for this demo, I'm opening this database for public access. If you're doing this for your work or for your hobbies, you probably want to restrict. In fact, you should restrict the firewall. But I'm not going to do that because I don't want to get into that level of detail at the moment. I'm also going to choose a SKU, which is a tier effectively. And it's going to be the standard B1 MS SKU. And that's because Azure actually gives you a 12-month free trial if you use that this SKU. And I certainly want to use that. So, and then there's a tier that you have to specify with that SKU, and that's called the burstable tier. So once that is done, I'm going to click enter. And what this is going to do is it's going to, oops. So this is what happens when you're doing a demo. You make spelling mistakes. So I'm going to go ahead and I'm going to fix this. And what it's trying to do is more spelling mistakes. What it is trying to do is it's trying to make a database, and this actually takes some time. So I'm actually not going to wait for this to finish working. What I'm going to do is show you what happens once it finishes working successfully, and that is over there on the next slide. So once this command runs, the output of this is it is a JSON string that looks like this, and it has some very important information that we're going to use. It has the name of your database. You can specify it, but it defaults to flexible server DB. It has a host name. It has a password that it automatically generates, and then it has a username. And now what you need to do is really save this information in variables locally so that you can go ahead and you can connect to the database from your local computer. And the way to do that is really by copy pasting this information. And the best way that I found to do this is I just open up a blank notebook and I copy paste the names of the server. So you can see over here, I've copy pasted the name of the server, the admin username, the admin password, and the flexible database name into these variables. So I'm going to go ahead, I'm going to copy this, and I'm going to go back to my terminal. I'm just going to cheat and open a new window, and I'm going to go ahead and in my demo folder in my repository, I've gone ahead and I've set up these variables, and you can double check that they were set up by using the echo command. So for example, if I do echo db name, it should give me the flexible server db. Now you have all of these different things like your username, password, db name. You don't quite have a full connection string. And as I mentioned, you're going to be connecting to Postgres, and to connect it, you need something called a connection string. And the connection string is really a combination of all of these different components. And there's a command that you can use to export a connection string. And what this command does that I've copied is that it takes the host name, it sets it up, it takes the database name, username, password, and it sets up SSL mode. And then what you have is a connection string. And now you can make sure that it's formatted correctly by echoing connection string, and then take the value that's been created and save it again in a text file that you'll be sure to not commit, and then just save it in a text file. Now this is just a text file. This is not something that I'm going to commit. It's you can almost think of it as a scratch pad. So I'm just going to save this. And now the next thing that I want to do is actually maybe try and connect to the database using all of these variables. So let's talk about how I'm going to be able to do that. But before that, let me just do a quick recap into what we learned. And what we learned was we activated the virtual environment, we installed the dependencies, we logged into Azure, we turned on parameter persistence, and then we created a database. Then we saved the credentials that came from that database, and then we exported them using something called a connection string. But you might be wondering, well, you have all these variables and this thing called connection string, like, why do you need it? Why is it so important? And that's where we go into the next part of this demo, which is actually loading the data into the database and actually retrieving it to make sure that it actually works. And that's where we need to think a little bit about this connection string. And the way to do that is I'm going to show you my code. There's a file called datawork.py. And if you scroll down, you're going to see this function called load data. And there's a file called coviddata.csv. This is actually just a CSV version of that table that I showed you. It's quite horrible to look at, which is why I gave you a table earlier on. And what it does is that it makes a connection to a database. So it connects it by actually detecting what the connection string was in your environment and using CyclePG2 to connect to the database. Then it drops any table, called raw data or vaccine data if it already exists. But if not, what it does is it goes ahead and it creates a raw data table which has everything in that CSV file, and then it also creates a more filtered vaccine data which only has the number of doses received, the country name, and the vaccine name. And the reason that I also kept the raw data is just as a best practice. So I know, what my starting point was. Generally in data science, you want to keep that. And so I can go ahead and I can call load data and load the data into the database. There's also a function called get all data, which simply gets all the data from the more filtered vaccine data table and blurts it out. Now, in order to call these functions from the command line, I've used something called Python Fire. It's a library that lets you call functions from the CLI directly. So I just have to write load data, and it's actually going to call load data, get all data, and other functions as well. So let's go ahead and actually do that. And to do that, I'm going to go ahead and I am going to go back here and back to my virtual environment where it was activated. And I'm going to do Python3 datawork.py load data. And hopefully it should say that the data was loaded successfully. No, it's going to say that there's an error. So let's see. I think it's because I did not have connections. Okay, yeah. So I set up the connection string in a different terminal than this one, and that's really what is causing the problem. So I just switched terminal. I'm back to the one with the connection string, and now I'm going to go ahead and do that. So let's do that. Datawork.py, load data. And now hopefully it should say that the data was transferred successfully. Remember, if it doesn't do that, it will give you an error message that says, your database's connection isn't working, and that's because the connection string isn't there. So I just did that, and it says that the data was loaded successfully. Now I'm a bit of a skeptic, so I want to make sure that it really did. So I'm going to call get all data. And you can see that it's giving me like the values from 3 columns, like a number, a country, and the type of vaccine. So it seems like we were able to succeed in loading data. So yeah, that's the big step that we just did in connecting to Azure Postgres database. So let's do a quick recap. We did load the data using the load data function. We also were able to retrieve the data using get all data. So now we downloaded it, and now we're connecting and easily talking to the Azure database for Postgres over here, which is the green cylinder. So next, what we're going to do is actually try and gather some insights and actually serve them locally using Fast API. And to do that, I'm going to show you some interesting functions that I've created. Now, like I mentioned, one of the things that I'm really interested in getting is figuring out market shares for all the various vaccines. And I've done these using a function called get vaccine percentages and get vaccine counts. And both of these functions, what they really do is they just select the data from the vaccine data table, and then they do some simple mathematics that has to do with summing things up. Now, I'm not going to go into like all of this logic. It's rather simple, and you can go into GitHub and review it yourself. But the most important thing that I want to tell you about here is that I can actually call these functions and get percentages for all the various countries. So let me try and do that. Let's get what the name of the function was, get country vaccine counts. So I can get all the counts for all the vaccines. So for example, for France, we have this much count for, all the different types. And of course, this feels a bit overwhelming, of course, because, these are just numbers. And maybe what I want to be more curious about is actually the percentages. So I can try and get the percentages now. And back to, let's say, Denmark, I can now see that, wow, it seems that Pfizer is really dominating the market with 86% of the market share, things like that. So this seems really cool. But again, the problem here is that I'm just typing things on my computer, and it's not really something that a website could have. So the next thing that I want to talk about is how we turn these little functions that I have here in this script, turn them into a backend API. And this is really where Fast API shines. And Fast API is a framework that you can use to build backend APIs really quickly. It's fast, it's asynchronous, and you can even give a response model type, and that enforces type checking and things like that, which is really good to have. And it's quite an upgrade from some of the other frameworks that there are. And so using Fast API, I created a thing called a backend API that's just /data. And what it does is that it actually just gets the vaccine percentages that I calculated earlier, and it just gives them to you if you go to that website. Similarly, I've also made 2 other APIs out of curiosity. One is called the most popular one, and it just finds the most popular vaccine out of all of them. And again, this isn't very complicated math. It's just a lot of lines that show you how to do that computation. And the opposite of that is the least popular data. And again, you can have that. So once you have the Fast API application running, you want to make sure that you can at least run it locally. And the way to do that is make sure that you're in the right repository, and then do this. EuroPython main app -- reload. And what EuroPython is, it's an ASCII server. And so that's the type of server that you need for your Fast API type apps. And so I'm going to click enter, and it's going to say that, oh, my app is running at localhost 8000. So let me go to localhost 8000. Let's go to data, and let's see what I see. if I go here, and cool, that big green thing is now over here. It's basically country data for all the countries. I can see, again, the percentages. Let me also get, I'm really curious to know what the most popular types are. And I see a lot of Pfizer, with some, is there any Moderna? It looks like in Liechtenstein, Moderna is the dominant one, but for most of them, it does seem that it's Pfizer. So it's a bit surprising to me because I thought it would be AstraZeneca. And this is why I love data science. You always learn these cool things. And let me see what the least popular vaccine type is. And it seems like that's also there also seems to be one predominantly least popular one, and that's the J&J vaccine, which is really surprising, but for whatever reason, that's how things are. So with that, we at least have an API that's serving all of these insights running locally. Before we deploy this for the world to see, let's do a quick recap on what we just learned. We learned that we could manipulate data using simple functions and use FHIR to call them from the CLI. We also created fast API-based APIs to showcase interesting data. And then we set up the server locally using EuroPython, and then finally we navigated to see the result. So there you have me. I am also connecting back to my own computer using localhost, but that computer is talking to Azure Database for Postgres because that was the connection string that I had. I never had any data running locally. So with that said, I'm going to go to the next step, which is actually launching the backend on Azure App Service. So it's all well and good that I have, this local host running, it's really cool, but, I want the world to see this API and consume it and do something interesting with it. And Azure makes that shockingly easy to do. And the way to do that is you just write AZ web app and you give your app a name. So I'm going to call it Europe COVID vaccine types, just that. And I'm going to click enter. And what it does is it's telling me that this kind of website doesn't exist. So it's trying to create a plan. It's creating a web app. And soon what it's going to try and do is it's going to take all the contents of my repository and push them out to Azure, like all the ones that are out there. And then what that's going to really enable this website to do is come back and actually show what the contents of these APIs look like. But the important thing that I want you to remember is that just because you're pushing code doesn't mean that you're actually connecting the pieces together. So there are two things that you need to do after you've done AZ Web App up, and you can do this actually while the deployment is still happening. And what you need to do is you need to go to portal.azure.com, and you need to go to Azure App Service, which is this guy. You can also search for App Service over here if you aren't able to find it, and just go here. And then within this search bar, search for the name of the name of the app that you created. So mine was called Europe COVID vaccine types. So that is this guy here. I'm going to click it, and I'm going to configure it so that it also has a connection string. Because remember, I only set the connection string over in my application when I was deploying locally. So the app does not know what it is. And if you might recall, I copy pasted that the output of the echo command. And the reason I did that was so that I could come back at this step and put the connection string over here, click OK. And then this is very important. Make sure you click save. And what it does is that it starts your app with this connection string. Now, the connection string is going to help your web app talk to your database, but it's not necessarily going to set up that Unicorn server. So that's really something that you need to do. And web apps uses Gunicorn, but you can actually specify the class. And the way to do this is using this command. So what you can do is you can say you want to set up Gunicorn with one worker. The class that you want to use for the setup is the unicorn one. Your code is going to be in a file called main, and your application is in a function called app. So once that's done, and don't worry about keeping all of this in your head. All of this is going to be referenced in both the README and in the slide deck. I'm going to click Save, and I'm going to click Continue. And once that is done, it's going to update the app settings. Let me actually see if my code has deployed successfully, and it looks like it has. It's actually given me a URL, and I'm going to go ahead, copy this URL, and try and go to it. And I'm going to go to the slash data endpoint, because as you know, that was the main one with all the data. So I'm going to go ahead and click Enter. And this is, of course, the moment of truth. And I can see that the backend is now available for the world to see. And all of this data is coming directly from Azure Web Apps. And the data is coming from Azure Database for Postgres Flexible Server. So let's do a quick recap. I know we went through a lot. Remember that I executed AZ Web App up. I gave it a name, and eventually that command completed. But while that was happening, I also set up a startup command, as well as set up the connection string, and then went to view the website. I went to /data, but you can also go to most popular or any other thing. And so at this point, what we have is, that's me. I'm actually able to communicate with Azure App Service, and App Service is able to connect directly to Azure Database for Postgres Flexible Server. So I'm in the cloud now, which is great. But there's something that I don't like right now, which is that all this website, it has so much text, and there's just not enough visualization, and I really want to change that. So let's go to the next part of this demo, which is creating a visualization by connecting to this backend API via Jupyter. And this is actually my favorite part of the demo. And all I've done over here is I have opened a Jupyter notebook. And what I've done is I've imported a few things, and not a big deal. I think I might need to restart the kernel here. Let's see. Okay, it looks like the kernel is dead, but it's all right because I already have all the information executed for this eventuality. What you can have is you can import all the things that you need, and you can make a request to your backend API. Now, I have several backup websites that enable you to do that, but you can go ahead and put in the name of the backend that we just created. So that would be this one. You can call the data, and then you can save the percentage data as a dictionary. And what Notebooks is going to do is it's going to give you this giant thing. And then what you can do is you can pick a country that you're very curious about. For example, Spain is one of my favorite European countries. And so what I can do is I can say, all right, let's look at Spain. Let's see what the vaccine distribution looks like. And I can use Matplotlib to actually show you what it looks like. So it looks like for Spain, Pfizer is really dominating the market with 67% market share. Johnson & Johnson is the least popular one. The second most popular is AstraZeneca. Third is Moderna. Now, this isn't the case with all the European countries. For example, for Liechtenstein, Moderna is actually the main vaccine. The second is Pfizer. But you can honestly do this for all the countries there are. And what I've noticed is, from Croatia, Luxembourg, Greece, Hungary, and unfortunately, I didn't have time to get all the colors just synced. Even Latvia, Sweden, Pfizer is really dominating the market share. It's not even much of a battle in most of these countries. And that's really interesting for me to know, because I know that AstraZeneca was really one of the first European vaccines that came out. So it's very interesting how the German-American collaboration there has really dominated the market. But that was it for the data insights. Let's do a very quick recap. Now, all that happened here was that I connected to Jupyter, and I used Jupyter to connect to Azure App Service by calling the API, and the App Service, of course, was talking to the database. And what it did was it gave me a nice, pretty plot to show people what the vaccine distributions look like. So with that said, we are actually at the end, and we can review the learning goals. Remember, I said that we're going to transfer data from the file to the cloud. We're going to gather insights. We're going to serve them with fast API. We're going to host them on the web. We're going to connect web apps, also known as Azure App Service, to Azure Postgres, and then we're going to visualize the data. And that was really the journey that we just took. So I have added the references here for the code, the README data on the vaccination, where I got it from, and the meanings of the different columns. They're all over here. But with that said, thank you so much for your time today. I loved giving this talk, and so I'm really excited to field any questions that you might have. Thank you. And one more thing, please reach out to me via Twitter or via email. Let me know how this talk went, what you learned, what you liked, what you maybe didn't like. I'm always game to hear more from you. So thank you so much.